Bright Tuty. Every student matters.
Hello dear students, my name is Amit Ajmani and we are continuing with our work and energy chapter. Now in the previous topic, if you have seen that, you must have observed about and learnt about the law of conservation of energy. Until now we have done work and the types of energy. Today we'll be talking about the rate of doing work. Now there are two people who are exactly doing the same work, but one of them completes it as a faster rate as compared to the other one. Why is it so? There are two bikes or two cars or any two particular vehicles which are running with different speeds. Why is it so? The actual secret lies behind this particular term, which is known as power, right? Normally also we see that if someone is able to do some work as compared to the other person who is unable to do it, we say that he has done it because he has got more power, right? He is more powerful. Similarly, the engine of the cars or the vehicles, this is a more powerful engine, right? So it is all dependent on the power that is basically making the person to do the same work but faster, right? Let us take an activity to prove our point. Consider two children, say A and B. Let us say that they weigh the same, right? They are having the same weight and they start climbing up a rope separately. Both reach a height of 8 meter. Now let us see. A is taking 15 seconds to reach that height and B is taking 20 seconds to accomplish the same task. Now what is the work done by each of them? The work done needs to be different because they are taking a different time even though the height which they are achieving is same. The work done probably is the same, but A has taken lesser time as compared to B to do that work, right? He has taken 15 seconds. Now why work done is the same? Because work done, we know that it is equal to F into S and F is equal to M into G into S can be taken as H. This we have learned in the earlier topics. Now the mass or multiplying it with G, it becomes the weight. We have studied it earlier. The weight of both the boys is same. The height which they are reaching is the same. Therefore, the work done will be same. But the time in which A is doing the same amount of work is lesser as compared to the time that B is taking. So therefore, who has done more work in a given time? Say in 1 second. Of course, it is A. And how is he able to do that work done in that lesser time? Because he must have got more power. So what exactly is this power? When we relate power, we say that power is the rate of doing work. Let us try to relate what exactly is power. Power is defined as the rate of doing work. The rate of doing work. Now students, wherever you see this particular words rate of, it simply means divided by time. Make it a point. Wherever it is rate of, it means divided by time. So I can say that power is basically work done, and since we have got rate of, that means divided by time. This will be power. So in other words, we can also say that power is a work done per unit time. Per means divided by, in how much time, how much work is done, that rate is known as power. Now one important thing is that we know that work done is basically related to the energy. So we can also define power as the rate of supplying energy. The rate at which energy is supplied to a body is power, because the energy supplied will only be forcing or making that body to do some work done. So we can say that power is the rate of energy supplied, or it is energy supplied per unit time. So we have got four definitions of power. What all? They are all actually one of the same thing, because we have studied earlier that work and energy, they are same thing, interchangeable, having the same units. So rate of doing work or rate of energy supplied, work done per unit time or energy supplied per unit time, it is one or the same thing. Got it? So this is power. In layman terms, how much work is done in how much time, that is power. Or how much energy a particular source is being supplied with in how much time, that is power. Got it? Now mathematically, if we relate, then power will be equal to work done upon time taken, or I can relate it with power is equal to energy upon time taken, as work done and energy are same, right? Fine. So let us relate power is equal to work done upon time, or I can say power is equal to energy upon time. Fine. We know that the SI unit of work done or energy is joule, which is represented by capital J, and the SI unit of time is second, which is represented by small s, right? So when I talk about power, the SI unit of power should be joule per second, but actually it is watt. The SI unit of power is watt by the famous scientist James Watt, right? And this watt is represented by capital W. Got it? Fine. So what is the SI unit of power? The SI unit of power is watt. Now there are two questions, as we have studied earlier also. First of all, we will be asked define watt or watts. So we will write that watt is the SI unit of power, that's it. But we may also be asked define 1 watt. Same thing, if you remember, whenever there is any unit being defined, being asked to define with 1, then in that case we relate it from the formula. And in case of watt, we know that power is equal to energy upon time or work done upon time. SI unit of power is watt, SI unit of energy is joules, and time is second. So if I need to relate the definition of 1 watt, I will be relating it from the formula, and it will be equal to 1 joule upon 1 second. Clear? Right? So how will I define it? I will say that the power of a source is 1 watt if 1 joule of energy is supplied to it in 1 second, or 1 watt will be the power if, relating the formula work done upon time, 1 joule of work is done by it in 1 second. Got it? Fine. So this will be how we are going to define 1 watt and of course watt. Clear to all? Now as we have seen in another units, similarly here also we have got few bigger units of power. Now what are those bigger units? The first bigger unit is kilowatt. Now whenever we add kilo, that simply means 1000 or 10 to the power 3 watt. In 1 kilowatt there are 10 to the power 3 watt. Another bigger unit is megawatt, represented by MW, and in 1 megawatt there are 10 to the power 6 watt. Fine. So this is about power. Got it? Now, when we talk about power, we are saying that it is the rate of doing some work, right? We are saying that it is the energy supplied to a particular object per unit time. So we have seen that power is equal to work done upon time or power is equal to energy upon time. Let us see, apart from the theoretical questions, what practical question we may get using this particular formula.